Hi, my name is Richard. Welcome to my online tutorials. Our discussion on numerical and computational method will be on numerical integration. So we are familiar with this simple integration problem. When we are asked to evaluate this finite integral, we use simple integration rule to evaluate this. After that, we substitute the limiting point. Thus, the integral of this will be 4x, and simple integration rule says that we should add 1 to the exponent and divide the function by that result. Then we substitute spanning from 1 to 2. So we get 4x exponent 4 all over 4 spanning from 1 to 2. Then this will give us x exponent 4 spanning from 1 to 2. So we substitute 1 minus, we substitute 2 minus, we substitute 1. That's 2 exponent 4 minus 1 exponent 4. 2 exponent 4, that's 16. 1 exponent 4, that's 1. 16 minus 1, that becomes 15. So we can say the integral spanning from 1 to 2 or 4x cubed dx is actually 15. The numerical integration comes in when we don't use simple integration rule to evaluate these finite integral problems. However, we use the values of the functions to evaluate this. When it comes to mind, there are a lot of methods we can use in doing numerical integrations. What are those methods? So anytime we are doing numerical integration, a lot of methods come into play. However, for the sake of our discussion, our attention will be based on 3 methods. And what are those methods? We have the trapezium rule, the Simpson 1/3 rule, and Simpson 3/8 rule. So before the video will end today, our attention will be based on the trapezium rule. So I will tell you how the trapezium rule is all about. Then we'll solve some integral problems using trapezium rules. So as I said, our attention today will be based on trapezium rule, and I will indulge you to check out my videos on Simpson 1/3 rule and Simpson 3/8 rule. So with the trapezium rule, it says that anytime we are asked to evaluate the integral spanning from a to b of any function f of x dx, then we need to get the table value for this function. That's x values spanning from x0 up to the last point of x, which is xn. And the last will be the value here, and the first will be these values. The other values will be gotten from the number of coordinates or the number of vertices that will be given to us. So the y0, the f of x produce the y0, y1, y2 up to yn. Then trapezium rule is telling us that our integral spanning from a to b of the function f of x dx will be equal to half h bracket, the first value of y here, the first value of the f of x, that's y0, plus the last one, which is yn, then plus 2 times the rest of the values, that's y1 plus y2 plus y3 plus y4 plus, in this case, y5. So this is all what the trapezium rule is telling us. Now what is our h? Our h will be equal to the interval between the x's. That's, it will be b minus a all over n, where the n is the number of vertices or trapezoid. However, at times coordinates will be given to us. So we said the number of vertices, which is n, will be equal to the number of coordinates minus 1. I hope you get that. So the number of coordinates minus 1 will give us the number of vertices or the number of trapezoid. So now we take some sample questions and see how we put this into practice. So let's solve our first example. They say using trapezium rule with 7 ordinates, evaluate the integral spanning from 0 to 3 of 1 all over x squared plus 1 ds correct to 2 decimal places. So you can't use simple integration rule to solve this. We are asked to use trapezium rule. So the first thing is to get the values of x and their corresponding values of y from this function. However, we can't get those values unless we find the h, which is the interval of difference. Remember, the x value span from 0 to 3. So the first one will be 0 and the last one will be 3. What of the rest? We need to get the interval of difference. So our h, remember we said, is equal to b minus a all over h, all over n, where n is the number of vertices. So remember, our b is 3, a is 0. What of the number of vertices? They say we should use 7 ordinates. And we say that number of vertices will be equal to the ordinates, the number of ordinates, okay, minus 1. So we can say our n now will be equal to the number of ordinates, which is 7, minus 1, that becomes 6. Then our h will be equal to b, which is 3, minus a, which is 0, over the number of vertices, which is 6. I hope you get that. So h will be equal to 3 over 6. And 3 out of 6 is half, which is 0.5. That means the interval of difference will be 0.5. From there, we need to construct a table values for x and y, where x will start from 0. The next one will be 0 plus 0.5, because the interval of difference is 0.5. The next one will be 0.5 plus 1, which is 1. The next one will be 1 plus 0.5, which is 1.5. 1.5 plus 0.5 is 2. 2 plus 0.5 will give me 2.5. Then 2.5 plus 0.5 will give me 3. That's the values of the x. Remember, it spans from 0 to 3. Now, having found that, we substitute the values of x into this function to get the corresponding values of y. So when we substitute the x values, now when we substitute 0, we'll get 1, and in that order. So the corresponding values of y equal to 1 all over x squared plus 1, when we substitute all the values of the x, are these values here. And what does trapezium rule say? The trapezium rule says that the integral of this function spanning from 0 to 3, that's 1 all over x squared plus 1 dx, will be equal to half h. Then in this case, our first value of y here, so our y naught plus, so this is y1, y2, y3, y4, y5, y6. So we have plus y6, then plus 2 bracket, y1 plus y2 plus y3 plus y4, then plus y5. I hope you get that. So this is our y0, y1, y2, y3, y4, y5, then y6. I hope you get that. So we just substitute. Remember, our h is also half, or 0.5. So we substitute that 0.5 bracket. Then our y0, which is 1, so 1, plus our y6, which is 0.1, so 0.1, then plus 2 bracket. Our y1 is 0.8 plus 0.5 plus 0.3076, then plus 0.2, then plus 0.1379. So what do we have thereafter? Remember, 1 over 2 times 0.5, that will be 1 over 4, which is 0.25. So when we add 1 to 0.1, we'll get 1.1, then plus 0.8 plus 0.5 plus 0.3076 plus 0.2 plus 0.1379 is 1.9455. So our 1.1, 2 times 1.9455 will be 3.391. Then 1.1 plus 3.391 will give us 4.991. Then times our 0.25 will give us 1.24775. So they say we should correct to 2 decimal places. Then we can say that our integral spanning from 1 to 3 of 1 all over x squared plus 1 dx using trapezium rule will be 1.25, correct to 2 decimal places. I hope you get that. We solve another more example on this so that you'll be abreast with the concepts. So our next example says that using trapezium rule with 6 vertices, calculate to 2 decimal places the approximate value of the integral spanning from 1 to 4 of dx all over x plus 3. So how do we solve this? Please, this can be rewritten as integral spanning from 1 to 4 of 1 all over x plus 3 dx. Don't get confused. So the first thing we need to do is to find our interval of difference, which is h, which is given as b minus a all over n. The b is the value here 4. Then the a is the value here 1. All over n, where n is the number of vertices. So they say with 6 vertices, so over 6. 4 minus 1, that will be 3. 3 divided by 6, that will be half or 0.5. Having known the interval difference, we construct table values of x spanning from 1 to 4 with an interval of, or with a difference of 0.5. So our table values for x will be 1. Remember the interval of difference is 0.5. So 1, then the next one will be 1.5, then 2, 2.5, 3, 3.5, then 4. Haven't gotten that value. When we substitute that value into the function 1 all over x plus 3, that's substituting 1 in place of x up to 4 in place of x, we'll get all these values for the y. So what does trapezium rule say? The trapezium rule says that our integral spanning from 1 to 4 of the function dx all over x plus 3 will be equal to 1 over 2h bracket. Our first value here, which is y0 plus, so y0, y1, y2, y3, y4, y5, y6. So plus y6, then plus 2 times the rest. That's y1 plus y2 plus y3 plus y4. Then in this case, plus y5. I hope you get that. So what is our h? Our h is 0.5 or half. So it will be equal to our y0, which is 0.250. And our y6, that's the last value. That's 1.143. Then plus 2 times our y1, which is 0.222, plus our y2, which is 0.200, plus our y3, which is 0.182, plus y4, which is 0.167, then plus y5, which is 0.154. So half times 0.5 will give us 1 over 4, which is 0.25, then equal to bracket. Now we'll add this and we evaluate. Okay, so as I said, when half multiplies 0.5, we get 0.25. Then 0.250 plus 1.143 will give us 0.393. Then so plus 2 times 0.222 plus 0.200 plus 0.182 plus 0.167 plus 0.154 will give us 0.925. 2 times that will be 1.85. So when we add it to the 0.393, we'll get 2.243 times our 0.25 will be 0.5605. So correct to 2 decimal places, we can say that our integral spanning from 1 to 4 of the x all over x plus 3 will be equal to 0.56. Correct to 2 decimal places. I hope you get that. So this is very, very simple. Trapezium rule is very, very simple. So we'll solve one more example on this so that you'll be abreast with the concepts. So our third example says that using trapezium rule with 5 trapezoid, evaluate the integral spanning from 0 to 1 of the square root of 2x plus 1 dx correct to 2 decimal places. Before we do that, please remember to subscribe to my YouTube channel, like and comment on my videos. If you do this, it will make my YouTube channel grow more and I can record more mathematical content for you. I guess you will do that. Please do, to make my YouTube channel grow more. Now, how do we solve this? The first thing you need to find when anytime you are doing numerical integration is to find the interval of difference, which is the h. So our interval of difference here, h, is given as b minus a all over n, where n is the number of vertices or the number of trapezoid. So our h will be equal to, our b here is 1, that's the highest limit, a is 0, which is the lowest limit, over n, and the n is the number of trapezoid, which is 5. That will give us 1 out of 5, which is 0.2. So having known the interval of difference, we'll construct table values for x and the y, where y is equal to the square root of 2x plus 1. Then, having known the interval of difference, we construct the values of x starting from 0 to 1. So this will give us 0, the next one will be 0.2, the next one 0.4, 0.6, 0.8, 1.0, which is the last one. Then when we substitute the values of x, they are corresponding of values of y, where y is equal to the square root of 2x plus 1 will be 1, then 1.1832, 1.3416, and that would have to the 1.7320, having substitute the 1. So the trapezium rule is telling us that the integral of our function, that's the integral spanning from 0 to 1 of the square root of 2x plus 1 dx will be equal to 1 over 2h bracket. Remember our y naught, then plus y naught, y1, y2, y3, y4, y5. So plus y5, then plus 2 times the rest of the values of y, which is y1, y2, y3, y4, which is the last one. So what is our h? Remember, we find the h to be 0.2. So this will be equal to half times 0.2, then bracket our y naught, which is 1, plus our y5, which is 1.7320, then plus 2 times our y1, which is 1.1832, plus 1.3416, then plus 1.4832, then the last one, which is 1.6124. I hope you get that. So half times 0.2 will be 0.1, then bracket 1 plus 1.7320 will be 2.7320, then plus 2 times 1.1832 plus 1.3416 plus 1.4832 plus 1.6124 will give us 5.6204. So 2 times the 5.6204 will be 11.2408. Then when we add it to the 2.7320, we'll get 13.9728. Then when we multiply that by 0.1, our answer will be 1.39272. So we can say our integral spanning from 0 to 1 of the square root of 2x plus 1 dx will be equal to 1.10, correct to 2 decimal places. I hope you get that. So this is very simple. We'll solve one more example on this. So we'll solve our last example on this, but before we do that, please make sure you subscribe to my YouTube channel. This will make my YouTube channel grow more. Like and comment my video. You can pause the video and try solving. It says find the approximate area of the curve y is equal to sin x within the interval 0, pi using trapezium rule with 4 vertices. So remember, when it involves trapezium rule, we need to find the interval of difference. Also, when we are talking of area of a curve, then we are talking about the integral. So we are just asked to evaluate the integral spanning from 0 to pi of the function sin x dx. That becomes the area of the curve. I hope you get that. So we need to find the interval of difference h, which is equal to b minus a all over n, where n is the number of vertices or the number of trapezoid. So this will be equal to our b is pi, our a is 0, all over the number of trapezoid vertices is 4. So this will become pi over 4. And remember, since it involves trigonometric functions, this is pi over 4 in terms of degree. In terms of degree, it will be 45 degrees. So our interval of difference is 45 degrees, and pi in radian is pi over 4, and in degrees is 45 degrees. So we need to construct a table values for x. So we'll start from 0 because our integral start from 0 to pi, and that pi is 180 degrees. Pi in degree is 180. So we'll have 0, the next one will be 45 degrees, the next one will be 90 degrees, the next one will be 135, then 180 degrees being the last one. So we substitute this into this. Sin 0 will be 0, sin 45 will be 0.7071, sin 90 will be 1, sin 135 will be 0.7071, and sin 180 will be 0. So our trapezium rule is saying that our area of the curve, area, will be equal to 1 over 2h of the first function here, which is y0 plus y1, y2, y3, y4, plus y4, then plus 2 times the rest of the values of y, which is y1 plus y2, then plus y3. I hope you get that. So we have half. Our h is pi over 4. So pi over 4. Remember, pi is 3.142. So times our y0, which is 0. Our y4 is also 0. Then plus 2 times y1 is 0.7071. Then plus 1. Then plus 0.7071. I hope you get that. So half times pi over 4 will be pi over 8. Then times 0 plus 0 is 0. So we just have 2 times 0.7071 plus 1 plus 0.7071. I hope you get that. Remember, pi is 3.142 or 22 over 7 all over 8 times 2 times 0.7071 plus 1 plus 0.7071. So when we divide it by 3.142, that's the value of pi, we'll get 0.39275. And 0.7071 plus 1 plus 0.7071 will give us 2.4142. And when we multiply 2 by 2.4142, we'll get 4.8284. And so when we multiply 0.39275 by 4.8284, we get 1.8963. So remember they say correct to 3 decimal places. Then we can say that the area of the curve is 1.896, correct to 1.896 unit square, correct to 3 decimal places. I hope you get that. So we'll end it here today. Until we meet again, please, my name is Richie. Like, comment, and subscribe to my YouTube channel.